Welcome to Study Loop.
So in this problem, we are given the reaction of hydrogen and bromine, which produces hydrogen bromide, and we are given the initial mass of the hydrogen uh, and the initial mass of bromine, and then we are provided with the volume of the reaction vessel and also the mass of hydrogen at equilibrium. In, in first part of this problem, we have to find out the equilibrium concentration of each of the reactants and product present here. So to do that, what we have to do is first we have to find out the initial number of moles of hydrogen which is taking part in the reaction, and then we also have to find out the initial number of moles of bromine which are present of equilibrium uh, with the number of moles of hydrogen at equilibrium using this equilibrium mass of hydrogen. We can find out the equilibrium concentration of each of the reactant and product. So the first step here is to find out the initial number of moles of hydrogen and bromine. So number of moles of hydrogen initial will be the mass of hydrogen, initial mass, which is 1.374 gram over the molar mass of hydrogen, which is 2.016 gram per mole. And from here we'll get a value of 0.68 mole, which is the number of mole of hydrogen initially. Then we can find out the number of moles of bromine initial. So this is again the mass of bromine, which is 70.31 gram over the molar mass, which is 159.81 gram per mole. And from here we'll get a value of 0.44 mole. So this is the number of moles of bromine initially, and then we can find the number of mole of hydrogen in the at the equilibrium. So that will be the mass of hydrogen at the equilibrium, which is 0.566 gram over the molar mass of hydrogen, which is 2.016 gram per mole. And from here we'll get a value of 0.28 mole. Now we'll have to set up the ice table to find the equilibrium number of moles for each of the reactants and products. So we have here H2 plus Br2 producing 2HBr. Now the initial number of moles, so these are the number of moles in this row, in this column, and the initial number of moles of hydrogen is we have calculated as 0.68. The initial number of moles of bromine we have calculated as 0.44, and the initial number of mole of the product will be 0. Then if we consider the change as x, then the change in hydrogen number of moles will be minus x. the value of this, which is 0.28 mole. So from here we can find the value of X, which will be 0.40 mole. Now from the value of X we can find the number of moles of the other reactant and product. So the number of moles of bromine at equilibrium will be 0.44 minus 0.40, which will give us 0.04 mole, and the number of mole of HBr at equilibrium will be 2 times zero point 0.4, that means 0.80 mole. Now we know the number of moles of each of the reactant and product at equilibrium, which for hydrogen it is 0.28, then for bromine it is 0.04, and for HBr it is zero point 0.8. Now just dividing each number of moles by the volume of the reaction vessel, which is given as 2 liter, we can find the equilibrium concentration for each of the reactant product. So the equilibrium concentration of H2 will be number of moles of H2, which is 0.28 mole over the volume 2 liter, and this will give us a value of 0.14 molar. Then the equilibrium concentration for bromine will be equal to the number of moles of bromine, which is 0.04 mole over the volume 2 liter, and this will give us a value of 0.02 mole. And finally the equilibrium concentration of HBr will be equal to 0.80 mole over 2 liter, which is the volume of the reaction vessel, and this value will be 0.40 molar. So these are the equilibrium concentration for each of the reactant and product. Now in second part of this reaction you have to calculate the value of Kc for this reaction. As you know that the expression of Kc is the concentration of the products over the concentration of the reactants. So the concentration of the product will be Hi, and since we have 2 as a coefficient of Hi, we'll have to put um, a square as the power of Hi, and then we have the reactant concentrations as H2 and Br2, and since there is no since the coefficients for both H2 and Br2 are 1, that means we don't need to raise the power for them. So the values we have already calculated, so it will be 0.40 square, which is the equilibrium concentration of Hi, over 0.14 times 0.02, and from here we can get a value of 57.14, and this is the Kc value for this reaction given.